Today we're going to be talking about price elasticity of demand. Let's say we're given the equation at the top left here and told to analyze the elasticity of the function, including finding out what price elasticity is unitary and what intervals are elastic and inelastic. Up at the top, we see our demand equation on the left and the elasticity formula on the right. To use the elasticity formula, we know we will have to find f of p and its derivative. Since x by itself is on the left, we know that the equation we have been given in the upper left-hand corner is in the proper form, and we can jump right into finding the derivative. First, let's distribute the 1/5. Now, since 45 is a constant, its derivative is 0, and the derivative of negative 1/5 p squared is just negative 2/5 p by applying the general power rule. So now we have all the components to the elasticity formula. Let's put it together. Negative p multiplied by negative 2/5 p over, and let's just use our original version of f of p here. You'll see why in a second. Alright, now the numerator becomes 2/5 p squared, and again let's use the same form in our denominator. We have fractions in our numerator and denominator, which isn't ideal for finding unitary elasticity. To get rid of the fractions, we can multiply the numerator and the denominator by 5, recognizing that multiplying our equation by 5 divided by 5 is essentially multiplying by 1, which doesn't actually change our equation, it just changes the form. And now our simplified elasticity equation is much easier to work with. We can now set E of p equal to 1 and solve for p to find the price at which elasticity is unitary. Most times we set equations equal to 0, so remember that when working with elasticity, we set our equation equal to 1, not 0. We'll learn why this is in just a minute. So let's set our simplified elasticity equation equal to 1 and solve for p. This is pretty simple algebra, so let's fast forward to the result. We find two solutions to this equation since the square root of p squared gives us a positive and a negative solution. But we know in the real world price cannot be negative, so we can just ignore the negative solution, and the price at which elasticity is unitary is approximately $8.66. This 8.66 breaks our number line up into two intervals, but we don't know whether the intervals are elastic or inelastic. We have an equation that tells us the elasticity at any price, and we know that the elasticity of less than 1 means the interval is inelastic, and more than 1 is elastic. So let's just pick test points on either side of 8.66 and plug them into our elasticity formula. The elasticity at a price of $8 is 0.795, so the left side is inelastic, and the elasticity at a price of $9 is 1.125, so the right side is elastic. I said earlier there's a reason we care about the number 1 when dealing with elasticity, so let's go back to that now by interpreting elasticity. Well, we know from economics that price and quantity demanded always move in opposite directions. If the price is high, consumers will buy less and vice versa, but elasticity tells us by how much. Let's look at the interpretation of the inelastic interval first. So if the price increases by 1%, demand will decrease by 0.795%. This means that our revenue will actually increase overall because our price increase offsets our demand decrease. And it works the other way around too. If price decreases by 1%, then demand will increase by 0.795%, but our revenue will decrease overall because now our price decrease was more influential than the few new consumers who chose to buy our product. Now let's look at what happens in the elastic interval. So if the price increases by 1%, demand will decrease by 1.125%. This means that our revenue will actually decrease overall because our price increase was overshadowed by the demand decrease. Another way to say this is that our price increase didn't outweigh the customers we lost by raising prices. And if price decreases by 1%, then demand will increase by 1.125%. So now our revenue will increase overall because our price decrease encouraged a lot of new customers, which offset the money that we lost when we dropped the price. The reason why the number 1 is important here is because it tells us whether the demand increase or decrease will offset the price increase or decrease. In summary, in an elastic interval, price and revenue move in the same direction, but in an elastic interval, price and revenue move in opposite directions.